Good morning, children. We are already doing questions based on continuous functions. We are checking the continuity at certain point or in an interval. So proceeding with the questions based on same nature. Here we are going to find all the points of discontinuity for which the function is defined like this. You can see x can be any real number. So we need to see for all real values of x, is there any point, any real number for which this function will not be continuous. So if we look at the definition quickly, you will find for all x greater than 2 and for all x strictly less than 2. Fx being a polynomial function, it will be continuous. So fx being a polynomial function is continuous. So what is the only point we have to check? We need to check the continuity at the point 2. Okay, so it is continuous at all the points other than 2. At 2 we need to check it. So at x is equal to 2, if you see the value of the function at 2, function is defined as x cube minus 3 for x is equal to 2. So when x is 2, fx comes out to be cube of 2 minus 3, that is 8 minus 3, which is equal to 5. And the left hand limit, as x approaches 2 from the left, again the function is defined as cube of x minus 3. Because it is a polynomial function, we can replace x by 2 as it is not taking indeterminate form on replacing x by 2. So it is now cube of 2 minus 3. That is again 5. Okay. And the right hand limit, it will be limit x tending to 2 from the right. And the function on the right of 2 is x square plus 1. So replacing x by 2 here, we get square of 2 plus 1, that is 5. So you can see very quickly that value of the function at 2 is equal to the left hand limit, which is further equal to the right hand limit. So we had already shown for all the real numbers less than and greater than 2, the function is continuous, and here we have shown fx is continuous at 2. So you can easily make out there is no point of discontinuity. Okay, so this means fx is continuous. This is 2. Fx is continuous for all real numbers, for all x belonging to R. So no point of discontinuity. Fine. Okay, let us verify the same for the next one. Again you can see it is a polynomial function. So at least for x greater than 1 and for all x less than 1, we can give the reason, same reason, it is a polynomial function, so it will be continuous. So fx being a polynomial function is continuous. At 1 we need to check it. Okay, we will see if we are able to show any of the 3 required terms. If any 2 are not equal, we will be able to say it is not continuous. So at x is equal to 1, if I evaluate f1, you can see on the when x is equal to 1, the function is to be taken as x raised to the power 10 minus 1. So it will be 1 raised to the power 10 minus 1. It comes out to be 1 minus 1, which is 0. And if we try the function on the right, it will be limit x tending to 1 from the right, fx. And what is fx here? It is square of x. So replace x by 1, we get 1 square, which is equal to 1 only. So what do we see? Value of the function at 1 is not equal to the right hand limit. So you can easily see we have located one point where the function is not continuous. So fx is discontinuous at x is equal to 1. So one point of discontinuity we could locate. Sorry. Now look at the next one. In this one, they are asking whether the given function is a continuous function or not. So again, it means the same. If we are able to show that for each real value of x, the function is continuous, it becomes a continuous function. If you are able to locate even a single point where the continuity is not met, we will not call it a continuous function. So you can see for x greater than 1 and for all x less than 1, fx is continuous. What is the reason? It is a polynomial function, so it is continuous. Fx is continuous being a polynomial function. So 1 may be a point of continuity or it may be a point of discontinuity. Okay, so at 1 we need to check. See, f1, when the function is equal to 1, when x is equal to 1, the function is to be treated as x plus 5. So it will be, f1 will be 1 plus 5, that comes out to be 6. And the right hand limit will be limit x tending to 1 from the right, and the function on the right of 1 is defined as x minus 5. So if I replace x by its value, that is 1 minus 5, because x is very close to 1 from the right. So the right hand limit, if you see, it is approaching minus 4. So look at these two terms, they are not equal. I have not evaluated left hand limit because we know that if we show any two of these are not equal, we will be able to come to the conclusion that it is not a continuous function. So we can write as f1 is not equal to the right hand limit. This means fx is discontinuous at x is equal to 1. Now because you have located one point of discontinuity, therefore we cannot say fx is a continuous function. We will write fx is not a continuous function. That means at 1, if we are plotting this function, you will see at 1 the continuity is going to break. We will have to lift our hand and then we will be able to proceed with the plotting as we move from left of 1 to the right of 1. Okay. Now see another one. This also talks about discussing the continuity of fx. You can see fx is defined as constant function in various intervals. Okay, so look, if I talk about these intervals, there are some endpoints also. If I say for all x strictly greater than 0, greater than equal to, let us include, because on the right of 0 also function is 3 and at 0 also the function is 3, so we can include this here. But less than 1, why 1 I am not including? Because it is defined in different way on the left and right of 1. So for all x belonging to this, fx is 3. What kind of function it is? A constant function. Therefore it will be continuous. Okay, therefore continuous. So within this it is continuous. In the same way, you can check for others. For all x greater than 1 but less than 3. Okay, fx is how much? It is 4. So same reason, a continuous function. Why continuous? Because it is constant. Okay. So till now what number we have not included? 1 we have not included. In the next part, for x greater than 3 and less than equal to 10. 10 I am including here because for on the left of 10 also and at 10 also the function is 5. Right of 10 we cannot check. It is a closed interval, you can see. Lower end is also closed, upper end is also closed. If you see separately each of them. So on the left of 0 I cannot evaluate, on the right of 10 we cannot evaluate. And on the left of 10, at 10 it is 5 only. So we can include it here, fx is continuous. It is 5, so continuous as it is a constant function. Okay, now let us talk about the points we have not yet included. So you will see there is scope for checking continuity at 1. There is scope for checking continuity at 3. We can easily show that it is discontinuous at 1. So at 1 we are checking. At 1, if you see the value of the function at 1, what is fx at 1? When x is equal to 1, fx is equal to 3. And what about the right hand limit? Right hand limit means when x is greater than 1. That means it is approaching 1 from the right side. So we need to use this part. On the right of 1, fx is equal to 4. So this is 4 only, which is not equal to 3. That means value of the function at 1. So you can see 1 is the point of discontinuity. Let us check for 3 also. You will see on the left of 3, fx is to be defined as 4. So I am first calculating left hand limit. So it will be limit x tending to 3 from the left fx. So on the left of 3, fx is equal to 4. Okay, so left hand limit is 4. And what about the value of the function at 3? Value of the function at 3, when x is equal to 3, fx is equal to 5. So this is not equal to the left hand limit. So at 1 as well as at 3, you could show that two of the required terms are not coming out to be equal. So therefore, what do we find? What are the possible points of discontinuity? We can say fx is discontinuous at x is equal to 1 and x is equal to 3. For rest all numbers from 0 to 10, fx is continuous. But from 0 to 10, we could locate 2 points, 1 and 3, where the function is discontinuous. Fine. Now see the next one. There can be two types in which the questions can be asked. Either you will be checking the continuity at the given point or in the given interval, or they will say that the function is continuous, and using that condition you will be finding the values of the unknowns involved in the function. So it is of that type. It says find the relationship between a and b so that the function f is defined by this. They are not saying find the value of a and b. Instead, they are saying find the relationship between a and b. The reason being, uh, the given information is not sufficient to find the values of a and b separately. Whatever condition is given, with that we can only find the relationship between a and b. Okay, so they are saying the function is continuous at 3. So this is what we are going to use. So we can say as fx is continuous at x is equal to 3. Therefore, what can we say? The left hand limit should be equal to the right hand limit, and that should be equal to the value of the function at 3. All these three things should be equal. Okay, let us write all these. Left hand limit will be limit x tending to 3 from the left. So you see what is the function on the left of 3. When x is less than 3, function is to be taken as ax plus 1. And on the right of 3, when x is approaching 3 from the right, see this part, when x is greater than 3, function is to be taken as bx plus 3. So we'll write bx plus 3. This is on the right of 3. And this should be further equal to the value of the function at 3. So when x is equal to 3, the function is ax plus 1. Here we will replace x by 3. So f3 is 3a plus 1. Okay, now see, this is a polynomial function, this is also a polynomial function. If we replace x by 3 in both these terms, they will not take indeterminate form. So we can go for direct substitution. So thrice of a plus 1 is equal to thrice of b plus 3. This is equal to thrice of a plus 1. So we don't need to write it again. Now if we simplify this, shifting thrice of b to the left, we get 3a minus 3b is equal to, and shifting 1 to the right, 3 minus 1 comes out to be 2. So we get a minus b is equal to 2 by 3. If I take 3 common, or you can write a is equal to 2 by 3 plus B. So this is the relation between A and B. Okay, provided there was one more condition given using which it was possible to find one more equation in terms of A and B, then it was possible to calculate A and B separately. Here we are getting only one linear equation in terms of A and B, so we could not evaluate them separately. Now see the next one. They are saying show that the function defined by gx is equal to x minus greatest integer function x is discontinuous at all integral points. So if x is an integer, you have to show that is the point where the continuity of this is going to break. So we will assign x a value which is an integer, and then we will show it as discontinuous at that point. You can take 0, you can take positive integer, you can take negative integer. For each it can be checked. Let us do for 0 first. So for x is equal to 0, let us assume, see, if 0 will become 0 minus greatest integer function 0. Okay, so this 0 as it is, what is the greatest integer function of 0? It is 0 only. So the difference comes out to be 0. Let us take right hand limit. When x is tending to 0 from the right, when x will tend to 0 from the right, then fx will be limit, then the function right hand limit will be limit x tending to 0 from the right, and function is x minus greatest integer function x. Now we have to see what will be the greatest integer function x when x is on the right of 0. Now this x can be replaced by 0. You can check the number line and come to the conclusion. Say this is the number line and the point 0 is here. This is 1. So x is approaching 0 from here, right side. So what type of number it can be? It can be 0 0.1, 0 0.2, 0 0.999, whatever. But its greatest integer function will be 0 only. So the difference comes out to be 0. So these two are coming out to be same. Okay, let us check the left hand limit. It will be limit x tending to 0 from the left, x minus greatest integer function x. So this we need to evaluate. So replacing this x by 0, okay, let me put the limit also here. Limit x tending to 0 from the left, 0 minus greatest integer function at 0. Keep in mind x is approaching 0 from the left. Okay, if I extend this number line and say this point is minus 1. So x is approaching 0 from the left. So think about the type of value x must be having. It may be minus 0.0009, minus 0.001, something like here, some number over here. So if you look at this number line, you will find its greatest integer function will be minus 1. So if we simplify it, it comes out to be 0 minus, and the greatest integer function of this will come out to be minus 1. So the left hand limit is coming plus 1. So this is not equal to the right hand limit. So what can we say? Therefore, fx is discontinuous at x is equal to 0. So at 0 we have checked. You can assign some positive value to x. We can say let x is equal to, say, c, which is denoting a positive integer. Okay, now let us check the value of the function at c. So f at c will be c minus greatest integer function c. Because c is a positive integer, its greatest integer value will be c only. So we get the difference c minus c, which is equal to 0. Now I will check the left hand limit. I am purposely taking the left hand limit. You can see, because in the upper part we could see that the value of the function at 0 and the left hand limit, they were not coming same. The right hand limit and the value of the function at 0 were coming same. So we'll try to compare these. So on the left of c, x is approaching c from the left and the function is c minus greatest integer function c. So we need to check what it comes out to be. Okay, this c will remain c only. And what about the number on the left of c? The number on the left of c, I will again draw the number line. Say the number c is here, then the integer greater than that will be c plus 1. The integer 1 less than that will be c minus 1. These are all three are consecutive integers. You can see from here, you check. X is approaching c from the left, from here. Okay, so it is a number somewhere here. So its greatest integer function will be c minus 1. So when we solve this part, it comes out to be c minus 1. Now you open the bracket and check. C and c will get cancelled out and we get 1. So what do you see? The value of the function at c is not equal to the left hand limit. So you can easily check here that for any positive integral value also we have shown that it is not continuous. If you want to take some negative integer, okay, suppose x is equal to c, which is less than 0. Okay, so negative integer we are taking. Now at c, you can use this method only. At c, the value will come out to be 0 only. But on the left of c, it will be limit x tending to c from the left fx, which is c minus greatest integer function c. So it will be c minus, let me make this number, okay, why to put negative sign? We are defining it as a negative integer. So the number includes that negative sign. So if you look at this part, again same calculation you will get. On the left of c, the integer just before it, preceding integer is c minus 1. So the greatest integer function of c when c is approaching from, x is approaching c from the left side, it will be c minus 1. So it comes out to be 1, which is not equal to the value of the function at c. So therefore we can say fx is discontinuous for all x belonging to z. So no matter what integer it is, fx will come out to be discontinuous. Taking one last one, this we will only through justification we will prove. They are saying discuss the continuity of following functions. So you look at all these three cases. This is sum of sine and cosine function, difference of sine and cosine function. This is product of sine and cosine function. What do we know about the continuity of sine and cosine function? We know that sine and cosine function are everywhere continuous. So sine and cosine functions are everywhere continuous. Okay, so what can we say? Therefore, their sum, difference and product respectively will be continuous. Okay, because we have done in the algebra of continuous function, we know that if two functions are continuous, their sum will be continuous. If two functions are everywhere continuous, their difference will be continuous. And if two functions are everywhere continuous, their product will also be continuous. So therefore we can say fx is everywhere continuous for all the three parts. For part A, B and C. I hope you could get an idea how to check the continuity of a function using these examples.